We're going to continue our work with finding integrals of natural logs. Well, of an expression that leads us to have an answer that's a natural log. And I kind of give it away right here saying that we're going to use long division to expose a disguised form. So notice how the numerator and the denominator have the same degree. That's the first hint that we can use long division to expose a different form of this expression. So I'm going to come over here and I'm going to divide x squared plus 6x plus 1 by x squared plus 1. X squared goes into x squared once. That gives us x squared plus 1. We subtract. 6x minus nothing is 6x. X squared minus x squared went away. 1 minus 1 went away. 6x is our remainder. This is a degree 1. Our divisor is a degree 2. So when our remainder is 1 less degree than our divisor, we know that we've completed the long division. So x squared plus 6x plus 1 divided by x squared plus 1 is the same thing as 1 plus 6x over x squared plus 1. So I'm going to take this and I'm going to just make it, resize it so that I can have a little bit more room here. So I'm going to rewrite this as 1 plus 6x over x squared plus 1 dx. And then I can rewrite this as the integral of 1 dx plus the integral of 6x over x squared plus 1 dx. And now I can find the integral of each. The integral of dx is x. This right here is x. And this one, I believe we already did this in a previous problem. This is 3 times the natural log of x squared plus 1. And then, of course, we always add c, and we get our answer. So that's how we can use long division to expose a disguised form that will allow us to actually integrate the expression. Now, sometimes you'll think you'll need to divide using long division, but when you're dividing by a monomial, you can just divide each term by x squared. So you don't have to come off to the side to do this long division. You can actually just rewrite this. Because you're dividing by a monomial, you can just rewrite this as 3 plus 2 over x minus 1 over x squared dx. So no need to do long division when dividing by that monomial. So now we have the integral of 3 dx is 3x. The integral of 2 over x, that's going to be 2 times the natural log of the absolute value of x. And then minus 1 over x squared. Remember that that's going to be the integral. I'm going to put the negative on the outside of x to the negative 2 dx. So we go back to our rule where we add 1, divide by the new denominator, or the new exponent. So we'll have minus x to the negative 1 divided by negative 1. So I'm going to write this all out. 3x plus 2 times the natural log of the absolute value of x plus 1 over x plus c. And the reason that we were able to make that a positive is because of this negative and this negative becomes a positive. So here's a couple of more examples. We have 1 over 1 plus e to the negative x. So this is another type of problem where we have to be creative. And you wouldn't know to be creative in this way, and that's why I'm going to show you that when you have something like 1 over 1 plus an exponential, we're going to multiply both the numerator and the denominator by e to the x. So that's just multiplying by 1 inside the integral, which is completely allowed. We're just going to change what it looks like. We're not going to change its value. So now we have e to the x over e to the x plus 1. So it's going to help take care of that negative exponent, and it's going to now allow us to use u substitution. So if we let u equal e to the x plus 1, don't forget the dx, du is going to equal e to the x dx. See, now if we had done that here, if we had let u equal 1 plus e to the negative x, du would have equaled negative e to the negative x. And that's not what we had left over. And we can't just generate a term with a variable in it. You can only generate inside the integral a constant and then multiply that by the reciprocal of that constant on the outside. So that's why we had to manipulate. This doesn't work. So we had to manipulate by multiplying by that e to the x over e to the x. And now what we have is the integral of 1 over u times du. So we have the natural log of e to the x plus 1. E to the x will never be a negative value, so we'll be able to use parentheses there. Natural log of e to the x plus 1 plus c. However, this next example, we have to use long division. You could also use synthetic because you're dividing by a linear term, a linear expression with a lead coefficient of 1. So I'm going to do some synthetic division here. So I'm going to have x plus 2 plus 3 over x minus 1. So this is going to be the integral of x plus 2 plus 3 over x minus 1 dx. So from here, I believe that you can take over and you can find the integral of each term. And we should have the integral of x dx is x squared over 2. The integral of 2 is 2x. The integral of 3 over x minus 1, you're probably getting very good at that. Let u equal x minus 1. Du equals 1 dx. Taking that 3 to the outside, that would have given us 3 times the natural log of the absolute value of x minus 1, and then plus c. Okay, here are 3 for you to try. 3 for you to try. Make sure that you are relying on the examples I just showed you when you try each one. Each one is an example of one that I've provided. Okay, for this first one, 4x minus 3 times the natural log of the absolute value of x minus 2 over x plus c. And this second one, 2 times the natural log, in parentheses 1 plus e to the x, or you can have e to the x plus 1. I just kept everything in the order that it was, plus c. And the last one, if you got this, you know you've got it. X squared over 2 plus x plus 3 times the natural log of the absolute value of x plus 1 plus c.